So on this video, we're going to be explaining the even ones, and hopefully you guys could do the odd ones on your own. And if you need help, there'll be the other video uploaded so you could check your work. Let's take a look at number 2 here. Now on these instructions it says solve by graphing. So they would like you to, let's remember this first one. I want to zoom in. It says y equals negative x plus 7. So that one has the b value at 7, so it crosses at 7. 1, 2, 3, 4, 5, 6, 7 right here. So it crosses at 7. And what's the slope on the first one? Negative 1, right? So you're going to go down 1 over 1. And when you go down 1 over 1, you could keep going down 1 over 1 to extend the line as far as you need it to be. Whoops. Now let's look at the other equation and graph in a different color, and we want to find the point of intersection. The other one crosses at negative 1. So it crosses at negative 1, and it goes up 1 over 1. So the point of intersection is clearly right here. And what is this location? It's 1, 2, 3, 4, 1, 2, 3. So 4, 3. And they even give you a space down here, 4, 3 for your solution. Okay, so hopefully you guys could do that. Now, even though they're suggesting for you to solve by graphing, and it's great to solve by graphing because they're both in y equals mx plus b form, but you could technically use linear combinations, right? You could combine the lines. They're lined up, y's on top of y. They're not in standard form, but you still have y's on top of y's. So if I wanted to, I could eliminate, like, what is y and y? That's 2y. Equal sign comes down. What's negative x and positive x? That eliminates, right? So what's 7 and negative 1? 6. So that's a simple equation. How do you solve that? Divide by 2. So y equals 3 when you divide by 2. So we have one answer. If you wanted the other, you simply plug it in. Take the 3, plug it in right into the, y value. So you'd have 3 equals x minus 1. So that means plus 1 here, plus 1 over here, 4 equals x. X equals 4. So x is 4, y is 3, 4, 3. So notice I solved this 2 different ways. I graphed it, got the intersection 4, 3. I solved it with the elimination method, got the answer 4, 3. So on tomorrow's quiz, I'm not going to tell you have to use graphing. Like right here, the instructions say you have to use graphing. But in reality, you don't. Okay, you could use whatever method you like. I'm sorry. And like I said, on the previous, on a different video, I explained the odd ones. So on this one, I'm going to stick to the even ones. Now, I accidentally explained number 4 on a different video, but I want to take this opportunity right now to explain this one even a different way. So, and this might throw you off, right? I don't want to throw anybody off, but I do want to mention this. You could do whatever you want to an equation, okay? As long as you do it to every single term, to both sides of the equation. So check this out, guys. On the bottom equation, I see a 4, an 8, and a 4. So technically, I could make this equation easier if I divide everything by what? 4. By 4. Now, you could divide by 2. Now, see, this is something that I've never done before, and I'm just throwing it out there as an alternative, right? So if you wanted to, you could technically divide everything by 4, okay? Or even by a negative 4 if you wanted to. And maybe this is not a good idea, but I'm going to go with it anyway. Top equation is going to stay the same. 2x plus y equals negative 4. The bottom equation, I'm going to rewrite it. This becomes negative y equals 2x plus 1. And then I could change this bottom red equation into standard form to use elimination method by subtracting 2x and subtracting 2x. So my new standard form equation for that bottom equation would be negative 2x minus y equals 1. Does everybody understand that? And I want to rewrite it below the top original equation. Minus 2x minus y equals 1. So what happens right here? That cancels. You end up with nothing equaling negative 3. And what do you guys say about that? That's no solution. Now, what does that mean visually if you were to have graphed both of them?
It'd be 0, -3. I don't know.
Okay, how about this?
Wouldn't you be on the line?
Right here, by me doing this, I'm just kind of showing you that it doesn't matter which method you choose. Like, let's actually go through this and let's rewrite both of them in slope-intercept form so we could actually graph. Okay? So if I wanted to rewrite this top one, let's say in green, in slope-intercept form, I'd have to subtract 2x and subtract 2x. So my slope-intercept form equation will be y equals -2x minus 4. Now let's rewrite this bottom equation in red in slope-intercept form. Let's get y by itself. So let's go back to it and let's divide everything by -4 better. That way it'll be y by itself. So if I divide everything by -4, my new equation, I'm going to write it down here in red. That would be positive y equals -2x minus 1. So what we have now in slope-intercept form, y equals -2x minus 4 compared to y equals -2x minus 1. You know that they have the same exact slope, which means that they're parallel, which means that they would not intersect, which means no solution. So I'm just showing you all these different ways that you could solve these systems. Yeah.
In the test, is it going to be a priority?
On the test, you get to pick whatever you want. You want to solve with the elimination method? Go for it. You want to substitute? Go for it. You want to think about the graphs? Go for it. Let's move on to number 6. Down here, what could you do?
You can multiply the bottom one by 2.
You can multiply the bottom one by 2.
Or you could just cross out multiply the top one by -1.
Or the bottom one by -1. There are so many roads to the same place. It's totally up to you. Or even this, guys. This is something.
Should we change the x's that we can just cancel?
No, but look at why it's already there.
Now, you just go with whatever you feel more comfortable with. I don't even throw a curveball at you. Check this out. What if I notice that this is 2, this is 2, this is 4? It's all divisible by 2, right? So if I wanted to, how about this? Instead of multiplying it by something, you could divide it by 2, everything, or you could call it multiply it by 1/2. You could technically do that if you wanted to. This is really weird, right? Now you don't have to do this, but I'm just showing you all these different ways of doing it. The top one is going to be x plus y equals 2 if you divide everything by 2, right? The bottom one, I'm going to leave it the same, -x plus 2y equals 4. So by me dividing everything by 2 on the top, it now makes it able to eliminate x's.
Wait a minute.
So I'd get 3y equals 6, which means y equals 2.
Why didn't you just the bottom one times negative?
Okay.
Cancel out and come to 0.
All right, so if we're confused with that, okay, let's go back to the original. We're confused, all right? We're confused. But do you guys see how you could do that? If you're confused with that, then let's go back to the original and let's multiply the bottom one by a negative, yeah? To get the y's to cancel. If you multiply the bottom one by -1, then the top one's going to stay the same. I'm going to rewrite it. 2x plus 2y equals 4. The bottom one I'm going to change to positive x minus 2y equals -4. Okay, so if you like that, go for it. There's many roads to the same place. The 2y's cancel. The 2x plus x is 3x. The equal sign comes down, zeros right there. How do you solve that equation?
Divide by 3.
Divide by 3. What's your answer going to be?
I don't know.
0 divided by any number is 0. If you have nothing and you divide it into 3 pieces, it's still nothing, right? So x is 0. We still need to find the y value. So let's plug in the y value. Plug in the x value to find the y value. Plug in 0 right here. It'll say 0 equals 2y equals, or 0 plus 2y equals 4. So you really have the equation. When you plug in 0, you can have -0 plus 2y equals 4. Now we know -0 is not even necessary, so it's just 2y equals 4 divided by 2, divided by 2, y equals 2. So your ordered pair solution is 0, 2. I just wanted to show you an alternate route over here. See, we still got the y value of 2, by dividing the whole top equation by 2, we got the same y value, we would have gotten the same x value, but go with what you're comfortable with. If you automatically saw, oh, this is a positive 2y, I need this to be a negative 2y, yeah, multiply by negative 1. Or if you saw, I want to cancel out x's, this is a 2x, you can multiply this by 2, that would become a negative 2x, and the x's would cancel. There's so many roads to the same place. As long as you don't make any algebraic mistakes, you should get the same answer, get to the same answer. All right, that was number 6. Let's jump to number 8. Okay, so like I said right here, I'm seeing 9, 3, 6. I'm saying I could divide everything by 3, but you guys don't like dividing, right? So let's not do that.
Wait, can you divide both top and bottom?
You could divide the top by 2 and the bottom by 3?
Wait, can you do both?
Yeah, you could do both.
We'll do that.
But, I mean, do you want to do that?
It's pretty easy. I think dividing easy.
Okay, forget about dividing. I don't want to confuse anybody. Nathan, what do you want to do? So if you want to eliminate, if you want to use linear combinations and you want to eliminate x's, well, you'd have to. Y's are easier, right? 2 and 3 is easier than manipulating 6 and 9. So if you could change this to a negative 6 and that to a positive 6, then it would eliminate. So I want to change the top negative 2y to a negative 6 by multiplying by 3. And the bottom one, I want to change that negative 3y to a positive 6 by multiplying by negative 2. So the top equation, 3 times 6x, that's 18x. 3 times negative 2y, that's negative 6y. 3 times 8 is 24. The bottom equation, negative 2 times 9, that's negative 18x. Negative 2 times negative 3, positive 6. Negative 2 times 6 is negative 12. So we are ready to combine and eliminate, oh, I forgot the y on the bottom. We're ready to combine and eliminate those y values. However, the 18x's and the negative 18x cancels out, as well as the y's. They eliminate, but the 24 take away 12, that's still 12. The equal sign's still there. You have nothing left on the left side. So right there, that's impossible. 0 cannot equal 12, so you say no, as in no solution. What do you think? Now, how about this? Let's go a little deeper here. What does no solution mean? Graphically. Parallel. So if I were to change these to slope-intercept form, if I were to solve both of them for y equals, you would see that they have the same m value. You don't need to know that, but it's good to know. Let's jump to number 10, which is on the back side. All right, so what do you think? Do you think that elimination method is good here? Do you think substitution's best, right? I would say. So let's do substitution because y is already by itself. Y equals this stuff. So let's plug in this stuff into the y value. So let me rewrite my bottom equation. 3x minus y equals 3. And of course, I'm plugging in the negative 2x plus 2 right in there. Now, whenever you substitute, you're going to have to do multi-step equation here. Distributive property, then combining like terms. There's no number, but there is a minus sign that you need to distribute. So a minus minus 2x, that becomes positive 2x. The minus with the plus 2, that becomes a minus 2. In other words, you're changing the signs if you distribute a minus sign in there. On the outside, we still have the 3x. So we really have 3x plus 2x minus 2 equals 3. And we already distributed the minus sign, so you don't need the parentheses anymore. So when you go 3x plus 2x, combining like terms, that is 5x's. We have the minus 2 equals 3. We need to solve for x. What am I going to do next? Add 2 to both sides. So I'm going to go plus 2 here, plus 2 here. We're going to end up with a new equation that reads 5x equals 5. So if you divide by 5, x equals 1. So I put 1 in my first number of the ordered pair. X equals 1. So you have one number, you need the other. Take that 1 plug it right into the x value of any equation you want. Top equation is going to read y equals negative 2 times x, but we know that x is 1, and then plus 2. Don't forget about the plus 2 that's back here. Rewrite it there. So what is y going to equal? Y is simply going to equal negative 2 plus 2, and that's negative 2 plus 2 is 0. So y equals 0. So 1 comma 0 is your ordered pair. Let's jump to number 12. What do you say? Substitution?
Yeah.
Elimination. What do I have to do? Multiply the top by what? By negative 2. Okay, so if I multiply the top by negative 2 to eliminate the x's, okay, that's going to give me, let me go to the side here, negative 4x. What's negative 2 times negative 1y?
2y.
Positive 2y. And then negative 2 times negative 4? Positive 8. The bottom one we're not going to mess with. 4x minus 2y equals 6. Once again, these guys eliminate. These guys eliminate. 8 plus 6 is 14. What's the answer?
No solution.
No solution. So when you end up with something that's impossible, like this is definitely not true, you say no, no solution. If you would have ended up with 0 equals 0, that's always true. Always, that means like infinite, right? So infinitely many solutions. Let's look at number 14. Substitution? Alright. Take that negative 3x plus 7 and plug it into the y right there. So let me rewrite that bottom equation. 3x minus 2 times y equals 4. But of course the y value is going to be negative 3x plus 7. So let's distribute. Let's combine like terms. Let's solve. Let's distribute first. There's a minus 2 out there in the front. Negative 2 times negative 3x, that's a positive 6x. Negative 2 times positive 7, that's a negative 14. Bring down the 3x. Out of those three terms, you could combine the 3x with the 6x. And what do we get? 9x's. And we still have the minus 14, and we still have the equals, and we still have the 4. Minus 14 equals 4. Okay, so plus 14 to both sides. We're going to end up with 9x equaling 18. You get rid of that 9 by dividing by 9, dividing by 9. Yes, x equals 2. You have one answer, you need the other. Take the value of 2, plug it in right into the x. So we're going to have y equals negative 3 times 2 plus 7. Again, the 2 we're plugging right into the x position. So when we go negative 3 times 2, that's negative 6. And then negative 6 plus 7, y equals 1. So the ordered pair is 2, 1. That's number 14. Let's jump to number 16. So if you choose to cancel out y's, you'd have to multiply the bottom equation by 2. Top equation you're going to leave the same. 2x minus 2y equals 6. The bottom equation becomes 8x plus 2y equals 4. Now if you decided to cancel out x's, then you'd have to multiply the top one by negative 2, which is totally fine. There's many rows of the same place. So right here, we're going to cancel out y's. We end up with 10x equals 10. divide both sides by 10. That tells you that x equals 1. So that's one answer. To find the other, you simply plug in the 1 right into the x on any equation you'd like. 4 times 1 plus y equals 2. 4 plus y equals 2. Get rid of the 4 by doing the opposite, minus 4. What you do to one side, you must do to the other side of the equal sign. We end up with y equaling 2 take away 4 is negative 2. So you have your ordered pair answer 1, negative 2.
What if you plugged it into the...
If you would have decided to cancel out the x's instead of the y's, you get the same exact answer.
No, but you know how...
If you were to have decided to plug in the 1 into the top equation, you'd get the same exact answer. So there's many roads to the same place.
Well, some are just easier.
Some are quicker, right? Some are easier. Some are quicker. Okay, so I would start explaining 18. However, if you haven't noticed already, 18 or 17, 18, 19, 20, those are all identical to the class opener that we did. Identical. All right? So if you need help on this section, go back to the class opener, same exact question, same exact graph. Keep in mind, these are the first 4 questions of the quiz tomorrow.